and welcome back to another video with Indigo Math. Today I'm going to show you how to use the rules of logarithms in a complicated looking log question. Let's start. Now moving on to the part B, it says that we need to solve this equation here. So remember what I told you earlier, every time when we see our bases, we try to make them look the same. Do you realize here 4 and then there's a 2? Can I express 4 in terms of 2 as well and maybe use some sort of change of base rule? So just think about that. I'm going to show you how to do it now. So moving on to the part B, I'm just going to write the question down. Log base 4 x minus 3 plus log base 2 2x plus 1 to the power of half equals 1. Now, you see the thing is because again, like I see, the bases are different so we can't combine them. So I'm going to do a change of base rule so that I can eventually combine the logarithms together. Logically, we will pick the smaller number, so I'll use base 2. So log base 2 x minus 3 over log base 2 4. Now, see here, I'm changing base on this piece of logarithm here, and that's what I end up with. Plus log base 2 2x plus 1 to the power of half equals to 1. So I'm going to simplify the terms now, and same thing like what we did in the part A, you realize this 4 can actually be written as 2 squared, right? So I'm going to do the same thing here. I'll show you. Log 2x minus 3 over log 2. Instead of writing 4, I'll write 2 square plus log 2x plus 1 to the power of half equals to 1. Let's evaluate the terms. Remember, if I've got the power, I can bring it down and also realize that, this log base 2 to the 2 is just 1, right? Because the base is the same as the argument and we know by definition that's just 1. So I'm going to change that. Log 2x minus 3 over, remember I said bring the power down, so I'm going to do that. And this chunk here is just 1, so I'm not going to write that anymore. Plus, similarly, I'm also going to bring this power down. So bring it down, I will have plus half of a log 2x plus 1 equals to 1. Now let's look at the equation first. Do you realize they all have this common denominator of 2 rather? So I'm going to multiply this 2 to the other side so I don't need to deal with fractions anymore. So I don't like to deal with such complicated equations. So I get log 2x minus 3 plus log 2x plus 1 equals to, remember I said to multiply the 2 to the other side, and I'll get 2. Using our rules of logarithm, right, we can actually combine these two logarithms because you see both of them are of the same basis. So I'm going to show you how to apply the rules now. So if the base is the same, I can combine it in such a manner. I have a log base 2 x minus 3. Now if it's a plus and you want to combine, please remember to change it to a multiplication and not an addition. So I'm going to say x minus 3 times 2x plus 1, close up the bracket, equals to 2. Now I'm going to change this into a quadratic equation. I'm going to show you how to do that really just by using the definition of logarithms. By definition, this is the base, here is your argument, and this one here is the exponent. This is like the legit definition, but it's a bit hard to remember. So what I always tell my students is, remember like the Korean dish they eat, like bibimbap, like the BAP. So I always call these the base. Here is going to be the answer, and the 2 is the power. So this is like the bopping here, BAP. So I'll show you how I do it. Base 2 raised to the power of 2 will give me my answer of x minus 3 2x plus 1. So that's how I change a really complicated looking logarithmic equation into a very simple quadratic equation. So I'm going to solve the quadratic equation now. So similarly, just need to expand, simplify, then factorize. I will skip those multiplication and show you how to do it. So eventually I will end up with 2x minus 7 multiplied by x plus 1 equals to 0. Solving, I will have either x to be 7 over 2 or x to be -1. But you see, the thing is, which answer should we be picking? So I'm going to go back to the question and see, remember, for our logarithms, right, the argument cannot be negative. So I'm going to see, let's look at one of the expressions. So in the question here, we have got, I'm going to highlight in yellow, we have got this log 2 2x plus 1, right? So I'm going to try to use that as an example. So log base 2, I've got log base 2 2x plus 1 to the power of half. This is one of them. We know by definition that your argument here must never be negative. Now if I were to put this fella in, and if x was -1, do you realize I'll end up with log base 2, 2 times -1 plus 1. Doesn't this give -1? Then argument can't be negative. So very obviously, we should be rejecting this value of x, and hence, the correct value of x is just x equals to 7/2. So please take note, usually when you got two solutions for your logarithmic equations, please check and check. Maybe we might have to remove one of them, because remember, the argument for your logarithm must never be negative. So if you want to find out more, come and join us in our September crash course and show you how to think about all these more challenging questions, and also take you through some of these concepts and how we can apply them in the exam grade questions. Okay, that's it for your rules of logarithm, and I'll see you in our next episode with Indigo Math. Bye!